We will derive the derivative of trigonometry function. So I start with the sin x. So consider the function f of x is equal to sin x. And I want to find out what is f dash of x. Find the derivative. What is the derivative of the sin x? The definition of derivative of f of x is limit h tending to 0, f of x plus h minus f of x upon h. This is the definition of derivative. Using this definition, we will find out the derivative of sin x. So this will become limit h tending to 0. F of x is sin x. So in place of f of x, you'll write sin x. In place of f of x plus h. How do you calculate f of x plus h? Wherever x is there, replace it by x plus h. So sin of, in place of x, it will be x plus h minus sin x upon h. Now, to evaluate this limit, we shall use the formula limit theta tending to 0, sin theta upon theta is 1. This is the formula that we will be applying in this problem. So to apply this limit here is h tending to 0, limit h tending to 0. So naturally this formula will convert to limit h tending to 0, sin h upon h is 1. Suppose I have limit h tending to 0, sin 3h upon h. Now recap, how do you evaluate this limit? This limit is evaluated by making the angle and the denominator same. So it will be limit h tending to 0, sin 3h upon 3h into 3. Now the theta is 3h, denominator is also 3h, hence this whole answer is 1, so 1 into 3. So whenever we have a coefficient for h, we have to make the angle of sine and the denominator equal. This is done by dividing and multiplying by the whatever the coefficient of h. Now we will apply the formula sin c minus sin d. So limit h tending to 0, 2 cos, add both the angle x plus h plus x by 2 into sin x plus h minus x by 2. So which formula did we apply in this one? We applied the formula sin c minus sin d is 2 cos c plus d by 2 into sin c minus d by 2. So if you apply this trigonometric formula over here, we will change this x and this x will get cancelled. And you can see that sin h by 2 upon h. What did I say before? Limit theta tending to 0, sin theta upon theta is 1. So we can apply the formula over here. So this became limit h tending to 0, 2 cos 2x plus h by 2 into limit h tending to 0, sin h by 2 upon this h. I will divide by 2 and multiply with 2. Now this became 1 because sin theta upon theta is always 1. So when you apply the limit 2 cos, h is substituted directly by 0. So 2x plus 0 by 2 into 1 into 1 by 2. This 2 and this 2 get cancelled. So derivative of sin x becomes cos x. So we have learned that if the function is sin x, its derivative is nothing but cos x. So now onwards, whenever a function with sine comes, you don't have to do this whole process. We can directly say the derivative of sin x is cos x. So this is the first formula of trigonometry. Derivative of sin x is cos x. Now remaining formulae of derivative, 6 trigonometric functions derivative and calculating, but I will not write the whole step like this. I will do it directly. Now we are going to see how the derivative of cos x works. So I have taken the function as cos x. Derivative's definition, limit h tending to 0, f of x plus h minus f of x upon h. F of x plus h is replaced by cos x plus h and f of x is replaced by cos x. Cos c minus cos d formula is applied. Minus 2 sin c plus d by 2 c minus sin c minus d by 2 is applied. Then separated, here x and x will get cancelled. So sin theta upon theta can be applied. So this h is combined with it to make it h by 2, to make the sine angle same as the denominator, divided and multiplied with the 2 in the denominator. So we will end up, because of the negative sign, we will end up the answer as minus sin x. So my conclusion is, I have written the first formula in the second notation, We learned yesterday that derivative of can be denoted by d by dx. Whose derivative I want to calculate? Cos x derivative. I want to calculate cos x derivative. So what will I write? D by dx of cos x. Derivative of cos x is minus sin x. We will be using this notation all the time. We will be using this stuff. This notation is very rarely used, only for the derivation purpose we'll be using it. But as far as derivative is concerned, we will be using always d by dx to denote the derivative of a function. It is easier to write and fast we can do the operation. Derivative of tan x. Again, function is tan x. We need to calculate this derivative. So we use the definition, limit x tending to 0, f of x plus h minus f of x upon h. So don't forget the limit. Replace the function, f of x is tan x, f of x is tan x, f of x plus h, replace x by x plus h. Do not forget that. Then we need to calculate limit of this function. We need to use limit theta tending to 0 sin theta upon theta. It is a fixed formula for all trigonometric functions in limits. So tan is written as sin upon cos, sin angle is x plus h. So both will have the same angle, x plus h. Then what we have done, we have taken the LCM. When you take the LCM, you notice that sin x plus h will multiply with cos x plus h will multiply with sin x, and the numerator turns to sin a cos b minus cos a sin b. And you know that this is a formula of sin of a minus b. So we have applied this formula over here. Sin a cos b minus cos a sin b is sin of a minus b. A means the first angle, b means the second angle. So what happens is this x and this x will get cancelled. So we are left with sin h. So if once you see sin h, we can apply sin theta upon theta. So sin h upon h, we get the limit sin h upon h. And remaining directly we need to replace h by 0. So this will become cos x, this will become cos x. So 1 by cos square x into 1. Sin theta upon theta is 1. So we have applied limit theta tending to 0. Sin theta upon theta is 1. And we have got 1 in this place. So your answer became sec square x. 1 upon cos square is sec square x. So my conclusion, third, my formula, derivative of tan x. Derivative of tan x is sec square x. So we have derived three formulas till now. Derivative of sin x is cos x. Derivative of cos x is minus sin x. Derivative of tan x is sec square x. Do not think derivative of tan x is cot x. Derivative of tan x is sec square x. How square came? Because while taking the LCM, we have 2 cos coming in the denominator, and that 2 cos changed to cos square and we changed to sec square x. We will see how the derivative of cot x works. F of x is cot x. We want to find f dash of x. So use the definition of f dash of x. Replace f of x plus h by cot of x plus h. F of x by cot x. Cot theta is cos theta upon sin theta. Cos theta upon sin theta. Took the LCM. While taking the LCM, I purposely wrote sin first because sin A cos B minus cos A sin B. I arranged it already while writing in the same format starting with sin. So I took the sin x as first. And you know that sin A cos B minus cos A sin B is sin of A minus B. But note that the first angle x and second angle is x plus h. So while doing this, you will get a minus sign. Sin of minus h. Sin of minus theta is minus sin theta. So there will be a negative sign coming here. Again, the denominator will be sin x plus h into sin x. So naturally, your answer will turn up sin square x as well as a minus sign. So minus 1 upon sin square x. So you can write as minus cosec square x. Once again, sin into sin give you sin square x. Sin of minus h. This minus h came outside. So minus, because sin of minus theta is minus sin theta. So because of this reason, there is a negative sign over here. And hence your answer has a negative sign. So derivative of cot x, d by dx of cot x is minus cosec square x. Very interesting to see. See, cos starts with a C, negative sign. Cot starts with a C, negative sign. So whenever derivative of a trigonometric function which is starting with C, it will always end up with a negative sign. So you will notice that even cosec x also will have a negative sign. Now come to the formula sec x. So f of x is sec x. Substitute with sec x as sec x plus x minus sec x. We do not have any formula into limits with the sec. We have only formula with sine and sine. So sec is converted to cos. When we took the LCM, cos c minus cos d. The denominator LCM is cos x plus h into cos x. When we apply cos c minus cos d, there is a minus sign in the formula. Minus 2 sine c plus d by 2 sine c minus d by 2. Again, you notice that here h will be negative. So minus sine h by 2 will come here. Remaining terms will remain as it is. So I need to apply sine theta upon theta here. So divide and multiply with the 2. Naturally, this 2 and this 2 will get cancelled. So I am left with numerator sine x. H became 0. Sine 2x by 2, 2. So h2 and 2 got cancelled after h became 0. This became cos x into cos x. Then this 2 minus sign will get cancelled. So you are left with only sin x upon cos x into cos x, which I will write as tan x into sec x. So fifth formula, derivative of sec x. What I'll do is I'll repeat sec x first into tan x. So derivative of sec x is defined as, or derivative of sec x is derived as sec x into tan x. You have noticed that whenever I want to calculate derivative of a function, I need to apply this definition. But that is a very lengthy process. What we are going to learn in this particular chapter is that without using this definition, how to find the derivative of a function. Similarly, we can show derivative of other functions too by using this definition. Now, I am not making an attempt to show all of them. So now take it granted what I am writing on the board. So first, now left is sixth formula, derivative of cosec x. Naturally, cosec x will be obtained by 1 upon sine. So you will be ending up in 1 upon, numerator will end up in cos x. Denominator will end up in sin x into sin x. And there will be a negative sign. So you will be ending up in minus cosec x into cot x. Cosec 1 upon sine will give you cosec. Cos upon sine will give you cot x. As I told you before, whenever there is a c, there will be a negative sign. Now my next aim is to make you learn this formulae. To learn this formulae, first part I told you, whenever I differentiate a c function in a trigonometric ratio where c is present, it will have a negative sign. Now to learn further, I pair the trigonometric ratios. You can see sin x and cos x are the pairs. Tan x and sec x are the pairs. And cot x and cosec x are the pairs. You should first learn what are the pairs. Sine with cos, tan with, not with cot, tan is with the sec, and cot with cosec. This is the pairing that you first learn. So have a vision of this pairing first. Sine's derivative is cos. Cos derivative is minus sine because c, I told you, if it starts with a c, there will be a negative sign. Tan x derivative is obtained by squaring its pair. Tan x derivative is sec square x. Same way, cot x is obtained by squaring. Cot x derivative is cosec square x. Of course, c is there, so negative sign will occur. Sec x derivative is obtained by multiplying with itself. Multiply the pair. Sec x into tan x. Cosec x also is obtained by multiplying the pair. Very simple to remember. What are the pairs? Sine with cos, they are derivative of each other. Tan with sec x, if you find the derivative of tan x, square its pairs, that is square the sec x. If you find the derivative, if you want to find the derivative of sec x, multiply with its pair, sec x into tan x. Same procedure for cot and cosec, but c has a negative sign. So cot x derivative will be square of its pair and cosec x derivative will be product of this both. This picture, if you can remember, the formulae are easily remembered. Now we find out the derivative of exponential functions. What is the meaning of exponential function? Exponential function means base is a constant, power is the variable. We have also seen x to the power 10, base is variable, power is a constant. This is algebraic function. This is exponential. Try to understand the difference. Base is constant, here power is constant. We have learned the derivative of this such type of function. X to the power 10 is start from the power and reduce the power by 1. So x raised to 10 derivative is 10, x raised to 9. What will be the derivative of 10 raised to x? What will be the derivative of exponential function? Derivative of a raised to x will be a raised to x, repeat it, into log a to the base e, which can also be written as a to the power x into ln a. Log to the base e can be written as ln, natural log. Now what will be the derivative of e raised to x? It will be e raised to x. Naturally in place of a it has become e, but here it becomes log e to the base e. And you know that log e to the base e is 1. So derivative of e raised to x is e raised to x itself. So there is only one function whose derivative remains the same as the function itself, which is nothing but e to the power x. So e to the power x derivative will be always e raised to x itself. So we have learned now. Let's practice few questions on this. What is derivative of 5 to the power x? It is 5 raised to x into log 5 to the base e. We may not write the base after some time. What is derivative of e to the power x? It will remain as e to the power x only because log e to the base e is 1. What is the derivative of x to the power 5? Does it belong to the same category? How do you come to know? Here base is a variable, power is constant. Wherever power is constant, we have to learn what formula? Start from the power and reduce the power by 1. Try to understand the difference. Base is constant, repeat the question. Power is constant, start from the power. Base is constant, repeat. Repeat and log of the base. Power is constant, start from the power and reduce the power by 1. Now we find derivative of log x. Now when I write log x, the base of the log x is e. Derivative of log x is 1 by x. Now how do you get this formula? By our old definition, limit x tending to 0, f of x plus h minus f of x upon h. By using the definition only we have got this. But I am not making an attempt to derive them. I am just directly giving you the formula. So now the question asks, what will be the derivative of log x to the base any another number, not e? Then what you need to do is, we need to write log x upon log e. What I have done? Log a. What I have done? I have change the base. This is a property of log. What is the property of log? Change of base property. Log of x upon log of a. I kept the base of both log as e because that only has got formula. Now log a is a constant. Yesterday I told you, whenever a derivative of a constant to be done, remove the constant outside and find the derivative of x square. Same way, remove the constant outside and find the derivative of log x. Now I have a formula for derivative of log x. Derivative of log x is 1 by x. So this being a constant, we don't have to do anything. You can keep it as it is into 1 by x. You can also write 1 over log a to the base is log e to the base a into 1 by x. Not necessary. You need not by heart this formula. You need to only just remember, if base is anything else than e, you need to change the base and the base will become, that denominator will become a constant. So it will remain as it is. So your answer will become 1 over log a into derivative of log x, that is 1 by x. You need to just only know this procedure. You don't have to by heart this. Let us recap all the formulae once again. Derivative of a constant is 0. In a constant, there is no change in the variable. When x is changing, constant remains same. So there is no rate of change, no change in it. So the derivative of a constant is 0. Then we came to derivative of x to the power n. Whenever variable x is having a power, start from the power and reduce the power by 1. Then I want you to learn one more formula directly. Derivative of root x. Actually, we find out the derivative of root x by using the same formula. N became half. So 1 over 2 half. Root x raised to half derivative will be half x raised to minus half. So the root comes into denominator. So you need to learn this formula directly. Derivative of root x is 1 over 2 root x, so that we can operate the derivative faster. Then comes next derivative of trigonometric functions. Okay, before that I'll do exponential. Derivative of a to the power x. It is repeated a raised to x log a to the base c. Students do get confused between these two formulae, but always check is the base is a variable or power is a variable. Then derivative of e to the power x. It is e to the power x itself. So very easy to remember because there's no change in e to the power x. Then came derivative of log x. Now when you take log x, it is the base c. So derivative of log x is 1 by x. Then comes trigonometric functions. Derivative of sine x. What are the pairs? Sine with sine x pair is cos. So derivative of sine x is cos x. Derivative of cos x is c has come, so negative sine, and cos pair is sine, so derivative of cos x is minus sine x. Then we come to the next pair, tan x, and is pair of tan x is sec x, so derivative of tan x is square of its pair, so it will be sec square x. Then comes to derivative of sec x. The pair of sec x is tan x. So when you do reverse way, you need to multiply. So sec x into tan x. Next pair is cot x and cosec x are the pairs. Both of them have c in it. So there will be a negative sign. So derivative of cot x will be, because of c, negative sign. Pair is cosec. And when you do this way, it is square. So cosec square x. Lastly, derivative of cosec x. Again negative sign because c is present. And you need to product of it, cosec x into cot x. These many formulae you need to by heart it. You should learn this formula by writing 2 or 3 times. See that every formula here is by hearted permanently. Now let's have a look at the derivative of x squared sin x. X squared multiplied with sin x. How the derivative will end up. So I've used the definition of f dash of x. After f dash of x, f of x plus h is substituted. Wherever x is there, both x has been replaced by x plus h. And the function f of x is x squared sin x. So it is substituted as it is. Then x plus h the whole square is expanded. Then we notice that x square is multiplied with sin x plus h. So and here x square with the sin x, so x square is taken common. 2xh plus h is multiplied with this, so that's how we get the second term. Now this is same method that we will be applying for the derivative of sin x. So we will be arranging it in such a way that x square is as it is, sin c minus sin t formula, then sin theta upon theta formula, then here direct substitution of h because one h is taken common and can get cancelled with the denominator. So finally, we will end up in x square into cos x. All 2, this 2 and this 2 will get cancelled. And here you will get 2x into sin x. Now, importance is not in the derivation. I just wanted to show you that x square sin x, when you find the derivative, usually we think if I want to find the derivative of x square, derivative of x square is 2x, derivative of sin x is cos x. So the answer should be 2x into cos x. But this is wrong. Derivative of x square sin x, what do you notice? X square as it is, derivative of sin x, that became cos x. Sin x as it is, and derivative of x square. So what have you noticed? Whenever I want to find the derivative of product, So what we notice is derivative of x square sin x, how it happened. Derivative of x square sin x, how it happened. X square remained the same, so u will remain the same. I'm assuming u and v are two functions. U remains as it is. Cos x is the derivative of sin x. So find the derivative of the second function. Apply the formula of derivative of the second function. Then the second function sin x remains as it is. Second function sin x remains as it is. Then the derivative of the first function. So how it works? Derivative of product u into v. U remain as it is. Apply the formula on v. Then v remains as it is. Apply the formula on u, and both connected by plus sign. U into derivative of v plus v into derivative of u. So let's imagine I want to find the derivative of, let's say, I want to calculate derivative of x cube into tan x. If I have to go by this old procedure, it would take a lot of time for me to find the derivative. Now I can use this technique and get the answer. How will I do it? X cube remain as it is. Derivative of tan x plus tan x remains as it is. Derivative of x square, x cube. So my answer would be x cube into, what is the derivative of tan x? What is the pair? Tan x pair is sec x. So sec x square. So sec square x plus tan x into, now derivative of x cube, power. Power starts with the power, 3x square. So we can write the answer as x cube into derivative of tan x became sec square x. Tan x into derivative of x cube became 3x square. Let's practice one more. I want to calculate derivative of 2x square plus 1 into log x. So let's calculate derivative of this. Naturally, the derivative of product of two function. So 2x square plus 1 will remain as it is. Derivative of log x plus log x as it is. Derivative of 2x square plus 1. Now 2x square plus 1 remains as it is. Now derivative of log x, remember log to the base c, it is 1 over x. Derivative of log x is 1 by x plus log x into, how will you calculate derivative of 2x square? 2 is a constant with x square. So 2 will remain as it is. You will apply the derivative of x square, that is 2x. X square's derivative, x raised to n's derivative. How do you calculate derivative of x raised to n? Start from the power, reduce the power by 1. X square power, when you reduce by 1, it becomes x. And the derivative of constant alone would be 0. Hence, I can say my answer is 2x square plus 1 upon x plus 2 into 2x, 4x into log x. This would be my answer. Now, pause the video for 2 minutes. After pausing it, try to answer these 3 questions. After answering, check your answer with what I am writing on the board. So you need to pause it for 2 minutes and try to write the answers. First, let's see the answer for the first one. Product of two function, x raised to 4 into derivative of 10 raised to x plus 10 raised to x into derivative of x raised to 4. So your answer will be x raised to 4 into derivative of 10 raised to x. The formula, recap the formula and write so that you remember the formula. 10 raised to x log 10 plus 10 raised to x into 4x cube. So to make the problem look good, you can take x cube common, you can take 10 raised to x common. So I am writing x cube into 10 raised to x common. 1x will remain, x log 10. 10 raised to x is common, 4 is remaining, x cube is gone. So this is your answer. So x cube is taken common between the two. 10 raised to x is taken common. What is remaining in the bracket? Now let's see the next answer. E raised to x into cos x. Same way, e raised to x into derivative of cos x plus cos x into d by dx of e raised to x. So your answer became e raised to x. Formula for cos x minus c is there, minus sin x plus cos x into derivative of e raised to x. E raised to x derivative is the easiest of all. It remains the same. So e raised to x itself. So taking e raised to x common, minus sin x plus cos x. Then comes to, again, pause the video for 2 minutes, do the answer for this and check the answer. Cos x into d by dx of log x plus log x into d by dx of cos x. So your answer became cos x into derivative log x 1 by x plus log x into derivative of cos x minus sin x. So your answer became cos x upon x minus sin x into log x. That would be the answer. Practice the product rule 3-4 times. While practicing, learn the formula as well as the product rule. After learning the product rule, your mind will start thinking, how will we do the division rule, the quotient rule? That means I have two functions, one divided by the other, u upon v. How will I find the derivative of u upon v? So the same thing that you must remember, start from the denominator. From where to start? From the denominator. So v, derivative of u, find the derivative of the numerator, minus, now the numerator remains as it is, derivative of denominator divided by the square of the denominator. So once again, you must start from where? You must start from the denominator. Should I write the formula for derivative of v? No. We need to write v as it is. No change in v, no change in the denominator. But apply the formula of derivative for u. Numerator, you find the formula for u. Then minus sign. In product rule, we had plus sign. Now you have minus sign. Then you write the numerator, numerator as it is, and the derivative of the denominator. And finally, you need to divide by the square of the denominator. Let's try out with one problem. Derivative of sin x divided by x cube. So what should I do? I must start from where? I must start from the denominator, x cube. Then what should I do with the numerator? Write the derivative of numerator, d by dx of sin x. Minus. Now sin x as it is, derivative of the denominator. It's important to note that you must start from the denominator, and denominator kept as it is, derivative of the numerator, then numerator as it is, derivative of the denominator, connected by negative sign, divided by the square of the denominator, square of the denominator. So your answer became x cube into cos x minus sin x into 3x square whole divided by x to the power 6. 3 into 2, 6. Now what is common here? X square is common. If you take x square common, x cos x minus 3 sin x divided by x to the power 6. Now you can subtract the power. So final answer, x cos x minus 3 sin x divided by x to the power 4. 6 minus 2, 4. This is how you can apply the division rule. We need to practice a lot on this. You need to do the worksheet. In the drive, we have the worksheets. You practice worksheet till you learn this operation very clearly.